Cisco, the company that connected the internet. The internet is often described as one of humanity's greatest inventions, a global network connecting billions of people, businesses, universities, governments, entire economies. But here's a question most people never ask. How does information actually know where to go? When you send a message from California to London, watch a video hosted halfway around the world, or ask an AI a question from your phone, how does that information find its destination? The answer involves a technology most people never see: routers, networking equipment, digital infrastructure. And for much of the internet age, one company became synonymous with that infrastructure: Cisco, a company that didn't invent the internet, but helped connect it before the internet was everywhere. Today, connectivity feels automatic. Open a browser, tap an app, send a message. The network simply works. But in the early 1980s, networking was far more complicated. Computer networks existed. Universities had networks. Research institutions had networks. Government systems had networks. The problem was that many of these networks struggled to communicate efficiently with one another. The internet existed in a limited form, but scaling it into a global system remained an enormous challenge. The future would require something more. Not merely computers, not merely software. Connections. A Stanford problem. Like many Silicon Valley stories, Cisco's origins trace back to Stanford University. In 1984, Leonard Bosack and Sandy Lerner founded the company. Both had worked within Stanford's computing environment. Both understood a growing problem. Networks were multiplying, but connecting them remained difficult. The world needed better digital infrastructure. And infrastructure often becomes most valuable precisely when nobody notices it. Roads, power grids, railroads, financial systems. Networking would become the next great infrastructure challenge. What routers actually do. To understand Cisco, imagine a postal system. Letters move between cities, across countries, across continents. The system works because sorting centers continuously determine where each item should go. Routers perform a similar function for digital information. They direct data between networks, determine efficient paths, manage traffic, help information reach its destination. Without routers, modern digital communication becomes extraordinarily difficult. The internet isn't one giant computer. It's a vast collection of interconnected networks. Routers help those networks cooperate. And as the internet expanded, the need for reliable routing grew exponentially. The scaling challenge. One of the recurring themes throughout Bay origins is that invention and scaling are different problems. The internet already existed before Cisco. Its roots stretched back through ARPANET, DARPA, University Research Networks, TCP, IP protocol development. The foundational concepts had already emerged. Now came a different challenge. How do you connect millions of computers, then tens of millions, then hundreds of millions? How do you build infrastructure capable of supporting global communication? The challenge shifted from invention to expansion, and Cisco arrived at exactly the right moment. During the late 1980s and especially throughout the 1990s, internet adoption accelerated rapidly. Businesses connected offices. Universities expanded networks. Internet service providers grew. Governments increased digital connectivity. Demand exploded. Every new connection created additional complexity. And complexity creates opportunity. Cisco specialized in the equipment that made large-scale networking practical. Routers, networking software, inter-network communication systems. The company became one of the dominant suppliers of networking infrastructure throughout the internet boom. For years, Cisco equipment became deeply embedded in the systems powering global connectivity. Not visible, but essential. Most people remember the consumer side of the internet: web browsers, search engines, social networks, streaming platforms, smartphones. These are the visible layers. But visibility and importance are not the same thing. Every email, every website, every video stream, every digital transaction depends on physical infrastructure. Routers, switches, fiber networks, data centers, semiconductor devices. Infrastructure rarely receives headlines. Yet infrastructure determines what becomes possible. The internet didn't scale because websites existed. The internet scaled because someone built the systems capable of carrying the traffic. Cisco became one of those builders. If semiconductors served as the brains of modern computing, networking became its nervous system. Computers could process information. Networks allowed them to share it. The result was transformational. Organizations could collaborate across continents. Information could move instantly. Global communication became routine. Entire industries emerged around connectivity. Cloud computing, e-commerce, social media, video conferencing, artificial intelligence, all depend upon networks. And networks depend upon infrastructure. Cisco's story reveals a pattern we've seen repeatedly throughout Bay origins. Some of the Bay Area's most influential companies never became household brands. Wells Fargo built financial infrastructure. Fairchild built semiconductor infrastructure. Intel built computing infrastructure. Cisco built networking infrastructure. The most important companies are not always the most visible. Sometimes they create the platforms that allow others to succeed. Sometimes they build the roads rather than drive on them. And history repeatedly rewards the builders of roads. Throughout this series, we've explored how Silicon Valley became more than a collection of companies. It became an ecosystem built on layers. Stanford developed talent. Semiconductor firms developed computing power. Xerox PARC explored future interfaces. Apple brought computing into everyday life. Cisco connected it all. The company didn't invent the internet, but it helped create the infrastructure that allowed the internet to become global, reliable, scalable, practical. And once again, we encounter one of Silicon Valley's defining strengths. Not merely inventing technologies, but building the systems that allow technologies to spread. Which brings us back to the question at the heart of Bay origins. Why did it happen here? Perhaps because the Bay Area repeatedly produced companies that understood a simple truth. The future belongs not only to those who create breakthroughs, but also to those who build the infrastructure that allows breakthroughs to scale. The Innovator's Ledger. Lesson 1. Infrastructure creates exponential value. Cisco didn't create the internet. It helped the internet grow. The biggest opportunities often emerge from enabling other people's success. Lesson 2. Scaling is its own innovation. Inventing something is difficult. Making it work for billions of users is equally difficult. Organizations that master scaling often create enormous value. Lesson 3. Invisible products can have visible impact. Most people never interact directly with a router, yet routers help power much of modern life. The most influential innovations are not always consumer-facing. Sometimes the most valuable work happens behind the scenes. Founder's question. Cisco became essential because it solved a problem created by growth. As your industry expands, what new bottleneck will emerge? And could you be the company that solves it? Closing. The internet changed the world. But the internet did not scale itself. It required infrastructure, routing systems, networks, connections. And for decades, Cisco helped build those connections. The company became part of the connective tissue of the digital age. A reminder that behind every revolution lies a foundation, and behind every foundation are builders. This is Bay Origins, birthplace of the future.